battery sẽ cao hơn XL ha. This is a past paper in summer 2022, question number 20 of paper 11 for Europe. Okay. In the circuit shown, the battery has an EMF of 12 volt and negligible internal resistance. 3 identical resistors. It's very important that we know these resistors identical, which means they have the same resistance R, and R. Connected as shown, the resistors each have a resistance of 10 ohms. The resistor L here, this one, is removed. What is the change in potential at X? Change in potential at X at this point, X here. To solve this problem, to answer this question, we need to determine the potential at X in the two cases. The first case is when L is still connected parallel to K. So for this group of the two parallel resistors K and L, the total resistance of this group is R over 2. Okay, and compared to the resistance of the other resistor M here, which is R, the ratio of the resistance of the parallel group KL compared to resistance of M is R over 2. R over 2 compared to R. Because in this circuit, the current is the same. This is the current I passing through the resistor M. The current I there will split into the two current I over 2 and I over 2 passing through the two resistor K and L equally. The point is the ratio of these resistances R over 2 and R, the ratio is 1/2 compared to, anyway, this is half of R. We can call this ratio 1 to 2. Okay, the voltage applied to the across the two points, let's call this point here Y. Okay, or in other words, the voltage applied to the resistor K and L is VKL compared to VM, exactly the same with this ratio 1:2, and the total voltage is 12 volt, and therefore VKL here is 4 volt and VM is 8 volt. So the ratio of the resistances is the same as the ratio of the voltage. We can write it as follow: R1 over R2 equal to V1 over V2. Okay. Double resistance của RM này thì nó sẽ là double cái voltage 8 volt. Để cho total 8 cộng 4 bằng 12 ha. So we know that on the left side of this circuit, left side here, the positive terminal, it has the voltage of 12 volt, and on the right side the voltage is 0, and therefore for the voltage across K and L to be 4 volt here, meaning the voltage between the positive terminal and the point X, V positive terminal and X, that potential difference is 4 volt, this 4 volt. So the voltage at X here initially must be 8 volt there. So that 12 minus 8 is 4 volt. When the two resistors are connected in parallel, the potential at X is 8 volt there. This is the first information. Now when we remove the resistor L, the circuit involves only the two resistors connected in series with each other like this, R and R, each of 10 ohms. So now each resistor will have the same voltage, which is 6 volt, which is half of the voltage 12 volt of the battery, 6 volt and 6 volt. Similarly, this point connected to the positive terminal is 12 volt, so that for the voltage between this one is to be 6 volt. This point X, the potential here must be 6 volt. 6 volt there. So now the potential of X has changed from 8 volt to 6 volt, meaning it is to decrease up 2 volt. Therefore we choose the option B.